Da questo binario scende e arriva nella posizione di carico, di precarico.
The effort has already paid off for Podium founder and managing director Eddie Bernasconi, even if he is still a long way from his goal.
We have already seen some improvements, that it has brought something. We are also working on bringing in other machines and to be able to carry out these improvements in general on the whole procedure.
For Podium project manager Asia Savino and head of production Maurizio Mascitti, the reclaim journey is far from over. Although the first data and findings are now available, the support provided by software-based algorithms is still expandable for the engineers.
I think the more the software needs to be improved. We were perhaps one of the first, as far as our data board is concerned, to have this software was actually made just for us. So let's say it was a program, a tailor-made design. Let's say that.
In order to further adapt and improve the development until the end of the project, the Swiss furniture...
That's for sure.
Can we go? Are we live yet?
Yeah. Yeah, let's start. Okay, thank you.
So I think, or I hope that everyone can hear me out there. Welcome to all of you joining us from abroad. We're basically streaming from within Brussels, the Blue Point location, presenting to you today the 4 years of results that the Reclaim project has brought up. This is quite a premiere for us as well, having a live stream. So we don't cease to take on new challenges, much as it is true for the Reclaim project as such as well. My name is Melanie. I'm standing here with the coordinator of the project, Michael Peschl.
Yeah,
from. You have your own
yes,
microphone.
I have my own microphone. Hi, everybody.
And as a matter of fact, it's also his birthday today, so you can see how much.
Thank you.
Very happy birthday from all of us. How much of the commitment and dedication has been brought to this project. And we are very happy to show you some of the results live today. Michael is going. Afterwards, we'll go through the 5 pilots, the pilot partners that have contributed, and focus on some highlights. Afterwards, we will walk through the technologies that have been developed within the project and have a little interview round with I was told you are allowed and it's very welcome to have you pose your questions that you might have in the chat. We will go about this as follows. We will collect them, and after each individual section we will take some time to address the questions. So please, whenever you do have a question, raise them in the chat and we will be happy to get back to them. So I think for now we can start with the very first point, which is Reclaim in a nutshell, and a short presentation by Michael.
Yes, thanks a lot, Melanie, for the introduction. Yes, I'm very happy that you joined this live stream. I'm also very happy that a lot of partners of Reclaim could make it happen to come here, present the technologies, present their pilots, what we have achieved within the 3 years project. And as Melanie said, the first agenda point will be the presentation, a short presentation. So it's not about PowerPoint today, but it's about technology and showing what we have achieved. But a little bit of PowerPoint is required to just to everybody what we do have. So maybe we can start with the presentation. Very good. So this is the Reclaim project, a 4-year project within the European framework, funded by the European Commission. And this project is about increased productivity, as you can see on the screen. Hopefully you can see the screen. Increased productivity by also having resource efficiency. So it's about extending the lifetime of large industrial equipment. This is what the Commission asks about. You can see here the call and the call identifier. It's about extending the lifetime of large industrial equipment. We have 22 partners in the project, quite a lot, coming from 9 European countries. There's quite a high budget, which is over 15 million euros. And we started back in October 2019 with our project, exactly before COVID-19 came across the world. So this was also quite a challenge. So we extended the project a little bit from the first approach, having a project of 3.5 years. We extended it a little bit. Now we have a 4-year project, and in a few days, at the end of September, we are ending also with the project. Yes, the coordination is by my company, by myself, by Harms Wende in Germany. So what is Reclaim all about? It's about the strategies, as you can see, on the lifetime extension of machines. It's a very industry-driven project, so of course we do have research, we even do have some basic research in, but the major focus is on putting technology, developing technology in order to put it somewhere in industrial environment that it is working already. That's why we also have the demonstration in focus, so that we are going to production sites, which have different challenges, which have different equipment, which is very old, and we want to develop specific technology in order to extend their lifetime, coming from a common basis. The approach, how we are doing this, is about digital retrofitting. So we apply sensors, we apply actuators, we implemented intelligent algorithm for data analytics in order to identify whether, for example, a machine is performing well, or if there is in future somehow a malfunction expected, and then we can react properly on these upcoming issues. So this is also the starting point of the project. There are the demonstrators, there are the pilots having their old equipment, and we identified the issues what they have, and provided a tailored solution for each of those pilots. Because if there are no technologies available on that, there are only a few options what happened with equipment that is old. So you can leave it to rot, you can dispose it, you can sell it somehow, but this is not the, let's say, the approach that is somehow in the circular economy idea. So that's why we tried to come out of this issue and making that linear economy choices, transferring it to a circular approach. And this is then this you can see on the next slide. Yes, the Reclaim vision. The next, please. Okay, the circular economy approach. This is the very basis of Reclaim. It's about the extension of the lifetime of a machine that I already mentioned. So it's also about reusing the production equipment, reusing a part of production equipment, or maybe remanufacturing in order to make this equipment ready for another application. By the same time, we want to increase production efficiency. As I said, it's industry driven, so it's very much on being efficient in production. So for example,
doing maintenance only then when it's required, avoiding the degradation of a machine and a sudden malfunction, for example. And of course, we are also talking about environmental friendliness. We also want to implement technologies that are there for making a more sustainable environment. Next one, please. Yes. Yes, and this is all somehow compiled in this slide. So we are coming from old equipment that is very close to the end of its lifetime. We want to extend the lifetime of this equipment, and we do it basically by using digital retrofitting, by applying sensors, sensor networks, and based on that data, what we are gathering, we can then apply statistical physical models for the prognosis of the health of equipment, for example, for the prognosis of the degradation of the model, for the prognosis when this equipment, this specific equipment, will probably fail. We also take care about maintenance operations, so we implemented intelligent maintenance planning so that the downtime of machine or complete production lines is limited. And of course, everything somehow based on data analytics, big data analytics, and also partially artificial intelligence algorithms. Okay, next. As I said, it's an industry-driven project, and as I also said, it's very important for us to bring this industry already in working production or manufacturing environments. That's why we do have, five demonstration companies and 6 demonstration sites. We will go further on a little bit more in detail on this. But just briefly speaking, so we have one in Germany about welding. We have 2 of them with the company Gorenje in robotics and Emmerling. We have woodworking there. We have shoemaking. We have textiles. So as you can see, very, very different use cases, but basing on the same technology approach. The partners, of course, we do not only have the pilot, the demonstration partners, but we also need the technology partners that provide the technology for data sensing, for data analytics. There we have industrial partners. We have SMEs there with the guys who will take care about the, let's say, technology required for each pilot. And of course, in the next slide, we will also see that there are research and academic partners, institutes, in universities who basically provide the, let's say, the basic research, the basic algorithms for doing all that activities. Okay, I think this was already my last slide in this short presentation. Melanie. No questions so far?
So as we've been told, yes, apparently there's no questions.
Okay.
I would say that means that you've been super clear on
That's good.
how we've been going about the project and what was being done. So now it's the time for the second point of today, which is shedding some light on the pilot partners. And the thing that was mentioned before by Michael is that really in this project the focus was not only to develop technology and then afterwards apply it or implement it, but it was implemented within the project duration and to see what challenges we're facing and what we can achieve in those very concrete and specific use cases. So we're gonna go through them one by one, starting here with Gorenje as the first one. So maybe Michael, you can just say a few words about what was the specific use case that they have brought to the project, and then we can focus on a few highlights of what was achieved.
Yeah, sure. So yeah, Gorenje, probably somebody knows Gorenje. Okay, here we are. Somebody knows Gorenje, or maybe somebody has a dishwasher from Gorenje. So we are producing dishwashers and other white goods in Slovenia, and their major challenge was on the safety aspects in the production facility. Obviously, there were some safety issues, and also something with the environment that what they are targeting on. That, for example, there was oil leakage. There were other things what they want to tackle. But of course, it's also always in more or less every pilot that they are targeting on increasing the operational efficiency, the efficiency of the production line in terms of the throughput, or also in terms of the material usage.
All right. So we would move on to the next out of the 5 pilot partners, which is Fluchos.
Yes, Fluchos. They're from Spain. So Fluchos is a Spanish shoe manufacturer. So very different, as you can imagine, to the use case of Gorenje. So they're producing shoes in Spain, and there the one of the major focus was exactly it's the expected useful lifetime. So they wanted to increase the lifetime of their machines to up to 20%. This was relevant because those machines what they're using are specially tailored for them, so you cannot buy them on the market. So, but they're working perfectly for their purposes. But as you can also maybe see on the pictures, they're quite old, and that's why there's the challenge to extend the lifetime as much as possible by also focusing on gathering data from those processes, because they are forced to make a documentation of the production, and those machines, as you can imagine, do not have any interfaces for data communication. So that's what we also implemented there.
Okay, so basically giving old machines, analog machines, the functionality of gathering digital data and processing them to achieve the targets. The next one is yet quite different. So as we can see, we're here in the woodworking manufacturing space with Podium. But Michael, maybe you can have a few words on the pilot side there.
Yeah, also very different application. So Podium is in the south of Switzerland, and they are producing kitchen. So they're processing all materials, basically wood, but also other materials for producing kitchens. And as you can maybe see, those machines are not that old as the one of Fluchos. So they concentrated on different targets there. But of course also there, as I mentioned before, the equipment effectiveness is something that is really in focus. They wanted to increase or achieved to increase it by about 40%, by also keeping the operational effectiveness very, very high. This was also very, very relevant for them. And maybe we can go then to our Harms Wende.
To the home base.
Yeah,
yes.
the home base,
so
exactly.
To Harms Wende.
Yes, it's about a friction welding machine. So this is a machine that can join metals together by using the friction process. And for those machines, we are targeting on an expected useful lifetime. So nowadays we have a traditional selling model, and for selling those machines. So we offer it to a customer, they buy it, and they use it as long as they want to have it. We are targeting now a little bit more on leasing business model, that we say, okay, we want to extend the lifetime of the machine in order to give it to one client. But if this client does not require the machine anymore, we can maybe bring it back to us, remanufacture it, refurbish it, exchanging some parts, and bringing to another customer with maybe other application. So this was the major focus on our own pilot, I would say. Yeah.
And yet moving to another country and a completely different application with the textile manufacturing. and Solotex. I'm not quite sure if the targets and KPIs come across in the picture, but maybe just to give you a short wrap-up of the individual categories that we looked at. So one was safety and environment, as Michael pointed out, for the very first one for Gorenje, which was in focus there. Maintenance cost effectiveness was another target, operational effectiveness, equipment effectiveness, material and resource efficiency, and then not to forget the expected useful life, because in the end, all of the technical developments, the algorithms that have been developed, shall lead to a lifetime extension of the machines. But let's take a little bit of time as well to present the pilot of Solotex and what equipment or what machines maybe were in focus there, and which of the targets had been a highlight for them.
Yeah, Melanie, it's basically one machine, and it's really a large machine, yeah. I think it's about 20 meters or so long, and at the beginning of this machine you have the cotton, which is the base material for the textiles, so they put it in. And at the end of the machine there you have the cotton there, and also there the machine is pretty old, but it's also very tailored to their process, to their specific manufacturing ideas, and that's why they also targeting on extending this lifetime of the machine to a maximum, increasing it by at least 20%. But there's another use case what we applied there. As you can probably imagine, there is as the base material is cotton. There is a very different, depending on where the cotton has grown and where it came from, they have a different brightness of the material. So the one is more white, the other one is more yellow or so. But at the end, your textile should be always the same, with the same brightness, independent on which base material you put in. And that's why they are applying chemicals there. Yeah? So they have a bleaching process, applying chemicals, and in former times they just put a lot of chemicals there in order to just make it white. Yeah? But of course, of the environmental impact, it is required to put only that much amount of chemicals there, which is required for this. So what they applied is a sensor technology, a camera system, that recognizes the brightness of the base material of the cotton, and then puts that much chemicals for the bleaching process as it is urgently required. Yeah.
Maybe to conclude the section on the pilots, I find it quite outstanding that, for example, in this case of Solotex, we have a return on investment in under 2 years even. So from a business point of view, you can also say that it's quite an added value for the company to have been part of this project and making quite a lot of use of all the technology that was developed within it. Do we have some questions by now?
Some questions.
Okay.
The voice from nowhere behind the regime. So there are 2 questions from Jill. Are you using the same technologies and algorithms across the 5 pilots?
Did the question come across the audio?
You can repeat the question, maybe.
So are the 2 technologies?
Are you using the same technologies across the or algorithms?
I see.
Across the 5 pilots?
So if the same exact algorithms have been applied to all pilots, or if there had been different ones tailored to the individual pilots?
Yeah. So of course, I mean, SDs are very different processes, very different machines. We have tailored algorithms, of course, but they are based on, let's say, on a generic approach. So we did not develop independently, but we start with a generic approach and then tailored it to the specific pilots.
So there's another question. Maybe I'll pass the microphone.
Yes. There's another question. Have you made any tests to assess the training required to use the proposed technologies? Sounds very complicated.
I didn't get it. It was about the training or what?
So the question was, have you made any tests to assess the training required to use the proposed technologies?
Oh, okay. So we are in this phase actually. Of course, it is required that those technologies are usable for the operators there. So we did some training activities. We also made hackathons, for example, with students. So yes, we were aware of this. Yeah.
That's all for the moment.
Okay.
That's it. So then I would say, with this being set on the pilots and achievements, or also basically the indicators set and the KPIs that were of interest, we can start introducing technologies. We're going to do this one by one. So we'll have individual tables that we walk through, and we'll get to meet the people behind. Starting with Nikos from CERT in Greece. So let us just move around a little, bear with us, as you can tell. There's a little bit of organization to be done, and then we'll continue. Because as I think there will also be the sharing of the screen to the audience from abroad, so that you can follow along easily. There we go. So the first obstacle was taken. As I said, we have Nikos with us, and Nikos, let us just know what are we looking at, and introduce us to this. Can be considered kind of an overarching result, a decision support framework that has been built that brings together the different results of the sensors and the algorithms.
Yes, okay, hello.
I think you will have to use the mic. It's on already.
Okay. Serth is a technical manager in the project. We have a lot of responsibilities, so I'm going to show several videos from several things for which we are responsible. As responsible for the integrated Reclaim IoT platform, we are also responsible for implementing some cybersecurity mechanisms. Today I will show to you two mechanisms related to identity and access management. The first one is about role-based access control, where you see that we have now in the video two kinds of users. The user on the top has all the rights, whereas the user at the bottom is a simple user, not an admin, so he doesn't have some of the admin's rights. For example, it is not possible with a normal user to upload manual pilot data to the database, or train or delete a model. Okay, this was the first video. The second one is about context-based authentication. So we have another security mechanism related to the access to the Reclaim platform. So if a user tries to log in outside working hours or from another IP in another location, then a one-time password is requested as a second authentication mechanism. If it also fails, then the user cannot log in, even if credentials have been provided. So this is the one-time password with free OTP application, and then the user has logged in. We are responsible for several services which are based on algorithms. Now we will see a demo about the core algorithm of the decision support framework, which recommends to the end users the optimal policy of applying lifetime extension strategies to the industrial equipment. This means it decides which components need to be maintained or replaced or refurbished, the time frame when this needs to be done, and in terms of some key performance indicators which should be optimized over a large future time interval. So the algorithm is based on simulation. It simulates the KPIs based on different policies and finds the optimal policy in this way. So here in the figure we see, for example, the simulation of the key performance indicators. The most important is the economic factor, but we also have some environmental factors like scrap. In this case, this is from Gorenje pilot and especially the white enameling line. Here we see how the KPIs are simulated. We have one value for each day, and you see how the different weeks are separated. And here we see the stop intervals when the simulation says that we will have a stop, which can be a failure or a strategy, like replacement or maintenance.
Sorry. Thanks a lot. So as I understand it, or maybe to bring it to the audience, this is sort of the ultimate interface that the users presented with to give them the support for one or the other decision on lifetime extension for their equipment. And the input to this is coming from the individual other algorithms and technologies that have been developed within the project. So thanks a lot for the presentation, Nikos. And I think we'll move on to see.
We have also other two videos about other solutions.
As you can see, do we have the time? We will have to cut it short due to the timing. Okay. But as you can tell, and as Nikos introduced, there was a lot that was contributed by CERT. So ask him or pose questions towards him in case you would like to know more. Thanks a lot. Okay. So, coming to George next. We're staying within Greece, more or less.
That's right.
But maybe, George, you can tell us a little about the contribution by FINT in this case, our partner FINT, and what you can present to us or to the audience today.
Sure. Of course, thank you very much for the introduction. We are very, very happy to be, let's say, in this project, and by reaching, let's say, the results, we are very happy to see the pilots that they have achieved several KPIs through the technological achievements that we have in this project. So, Future Intelligence, what is bringing in this project is the part of the acquisition of data that's coming from the pilot, and we are actually bridging the machines with the Reclaim platform. So we are bringing all the equipment that is required in order to connect the PLCs, the machines, the sensors with the platform itself. We have implemented that in the 3 of the 5 pilots, and specifically it's in Gorenje, in Podium, and in Harms Wende. So what we want to show to you today is a short video where we are presenting the equipment that we have used and installed in the pilots, and especially this time we will show you about what we have done in Gorenje, so we can discuss a little bit what was the challenges and how we have achieved that during the project. So my colleague Kostas will do this short presentation.
Yep, sure. Hello. Hi. So let's start it from the beginning. Okay. We've installed 2 machine vision cameras, one in the cell A part of the production line, That's the starting point, let's say, of the production, where the tubs are manufactured for the dishwashers that Gorenje produces. In the start of the line, the operators place small parts on the inox plate that they use, so they can be spot welded later on. And due to the many different configurations that are available, this procedure is prone to errors because sometimes the parts are not correctly aligned in order to be welded, or some parts are missing, and so on. So we placed a machine vision camera and all the relevant hardware, which acquires images from the plant, from the specific position, and informs the operator if something is not placed correctly or not placed at all. In the cell B case now, in cell B, what is happening is that it's the place that these tabs are welded. It's the seam welding operation of the tabs. And the issue that Gorenje faces there is that it is pretty difficult to recognize if the welding is performed as it should, or if there is some malfunction during the welding. And that's pretty difficult to identify later on, because it's a lot of labor work in order to do so. So what we did was to install a thermal camera there, and the idea was to try and analyze the thermal footprint of the trail that is performed from the weld, and process that in real time and see if it is possible to identify issues there while the welding is performed. Of course, as George mentioned earlier, we are also responsible for acquiring all the data that can be sourced from the machines there. We're talking about machines that are legacy, some of them, some others were upgraded, so we had to develop a lot of services, of different services with different interfaces in order to collect this data in a uniform way, provide context to this data, and share them to the data handler of the project, where the rest of the partners could perform all the algorithm processing that was necessary. So, yeah, that was the Gorenje case.
Thank you very much to the two of you for presenting this to us. So as we could see, this is sort of a key element, tapping into the source of everything, equipping the machines with the sensors where the data gets collected so that it can then be processed, which brings us to the next candidate here, Eliseu. So now we're coming from a company to a university, University of Porto. So Portugal, and maybe you can introduce us a little to what UPorto has contributed to the project. And fault diagnosis is one keyword, but you can let us into the others as well.
Okay. Thank you, Melanie. Thank you, Michael. So regarding University of Porto, our focus on the Reclaim project was the development of predictive maintenance algorithms. So we take the data from the database that were already on the database, and we process the data in order to compute some useful indicators regarding the remaining useful lives of a component. In particular, for today we have a demo based on the data from the Gorenje case. As we see before, the data from Gorenje is regarding the spot welding. And basically for that case, we developed the algorithm and we install it in this device right here. So we install here the algorithm that runs on Python and the database and the dashboard to run everything on the same device. And afterwards, the algorithm is making predictions, and we can see the predictions here on a browser-based interface. We can see here the prediction of the remaining number of cycles of that electrode. So basically the algorithm is to predict when we need to replace the welding electrode of one of the robots that we have in Gorenje. And basically we have this remaining useful life, and associated with this prediction we have the probability of failure in the next cycles as the survival function gives us. And we have also some information regarding the sensor data that we are collecting from the use case that you can see in this part here of the bottom graph. And basically you can set thresholds to see if the variables pass that thresholds. And we have other indicators like the cycle time to see if we have a good performance on the machine or not, the counter of cycles, and the remaining number of hours. So with these algorithms we are able to compute some indicators that were useful for the operators to maintain their machines. We can also monitor these indicators on a cell phone. So for instance, if we go to a cell phone, we can also see the same information as we see on the browser. So from my side, basically, that is.
I don't want to show your private messages.
No. Okay, so it's everything.
So you can also connect it. You can also connect it to maintenance planning, then, right? What you did.
Exactly. So we can connect to this maintenance planning, so we can have the optimal time to perform the maintenance without wasting the electrode material. So we can take most profit about that resource.
Asking this because, of course, we are also in Harms Wende in resistance spot welding, so you're targeting more or less on the, let's say, product quality, because if the electrodes are too worn, then the product quality is not sufficient enough. But at the same time, it's about the maintenance planning to keep the production throughput, the effectiveness of the production as high as possible, right?
Yes, and mainly in that case, because in Gorenje they have 24 hours working, so it's crucial to maintain the machine working 24 hours, and if we are able to plan better, the maintenance is a good thing, a good tool that we have for the maintenance teams, so they can plan multiple maintenance and stop the line to maintain those components instead of stopping the line just to replace one component, for instance.
Okay, cool.
And later on we can ask Gorenje from the other side. But thank you very much.
What do you think about it?
Thank you very much, Eliseo. We do have a question, I'm being told.
So Jill seems very active.
Jill is
interested in our project.
Let me
And he asked, the remaining useful life algorithm runs on the device in real time, correct? And the second question is, but is it also trained there?
Wait a second. Regarding the first question, currently the algorithm is running on the device real time, but the data is data that we have already, historical data that we already have from the past, is not real time data. Regarding the second question, the algorithm also trains in the device, so we can retrain the algorithm. And in that case, every time that we perform the maintenance of the electrode, so when we replace the electrode, we send that information to the algorithm that retrains the algorithm with the new replacement information. So we can have updated predictions. And this occurs like every 3 weeks. That is the time where almost we replace one electrode in the Gorenje shop floor.
Okay.
all right, thank you.
Yeah.
So I
Thanks
think
a lot.
that was the one question that we've had in between. We can move on to the next partner.
Yeah.
Actually, we have two colleagues now standing
my
next to each other. So Dietmar is with us today, also from Harms Wende. we're going back to the core of production, welding metals and the machines behind. Obviously, we couldn't bring a welding machine, but you've brought the equipment that you've used to further enhance the machines, and maybe you can let us in on what you've done within Harms Wende.
Thanks, Melanie. Yeah. Harms Wende is more or less 20-25 years ago in the field of friction welding, and we have very old machines in the field at our customers. And for Reclaim, we have developed a very good shell to bring these old machines into the new worlds with new sensor information to get quality or better quality for the products. And for that, I have here a small example. What is friction welding? You can weld two parts together. That is not really feasible to join. In this case, we have copper and aluminum to bring these two parts together. My colleague will explain a little bit more about friction welding. Here I will explain a very short thing, what we develop here in Reclaim. In Reclaim, we develop here this control system that we cover the PLC system that we have at the moment in our old systems. And also we develop here a sensor box that we got all new sensor information into this box. We digitalize all this information and bring this information into the control system to bring the possibility to get the awareness of the machine, to get the better quality of a product. And due to that, we have here a small demonstration. We have here a motor. The normal motor of a friction welding is much bigger, but here in this case we have here a small model of a motor. We can turn it on, and then we see here in this rapid prototyping part that we can start recording here the sensor for vibration and also for microphone. And I turn it off. And we would like to see what is better, a vibration sensor or a microphone, to get this information. And what we see here on the black side, we have the microphone. The red side is the vibration sensor. Unfortunately, I speak here a little bit and the microphone hears all my voice. Usually you have here in the microphone signal no information for the awareness, but in the case of the vibration sensor, there's some signals. After this, if we see that our rapid prototype is working properly, we develop a real prototype that is more for industrial use, because our lightweight box for an edge device is directly mounted on a tool in front of a robot with many of dust and water and so on, and some disturbance. And yeah, now we bring this into a product system that will be shown later on my colleague in the demonstrator side. Yes, that's a very rough overview about our system in case of detect awareness and quality, and also to bring our old machines in case of a refurbishment into a new level of production. Yeah, that's more or less the rough overview. Thanks, Melanie.
Thank you so much, Dietmar. Yes, well, we've heard about first of all, the decision support framework. We've heard about gathering data, processing data, but there's one thing without which we couldn't have had this project, which is the key system in between, which is the data handler or the data repository, for which ICE in this project was responsible. I have with me Oscar. So Oscar, fill us in on ICE, ICE knowledge discovery, and what is meant by that.
Okay. Thank you very much, Melanie. So yes, starting from the data gathered at the by the Fint gateway, and then passing all the data to the repository before it's being served to the different algorithms, and at the end to the decision support framework. Okay, so here what we have is the repository, the Reclaim repository itself. Basically what we are doing is storing the data and preparing some initial calculations for the then being reused at the different algorithms, the ones presented by Elise or others. And these pre-calculations are what we have called the reclaim indexes. Okay, so the reclaim indexes they are based on three basic pillars. So we are basing the profiling of a machine, which is what the indexes provide, and in the health of the machine, in the productivity of the machine, and also on the performance of the machine. Okay, so the health of the machine is based on the time that has passed from the last error, between the different errors, and the units produced. Okay, so if we reach an index close to 99%, it means that the machine is really healthy, so there aren't any problems being foreseen. But the lower the number is, the worse the health of the machine is. Okay, and this is collocated with the other two indexes, with the throughput and the performance. Of course, the health will influence in the performance and the production of the machine, because when a machine isn't healthy, it will have less performance and it will have less production. Okay, so
they're not completely independent.
They are completely independent, but somehow they are related as well. Okay, so for that we developed these formulas in where we have. No, it's okay. So we have the health. It's the mean time between failures and the production hours. Then the performance is the actual production divided by the maximum production, and finally the throughput, which is the units produced against the production time. And all this is being calculated and shown in this chart. Okay, so here in the case of Podium, okay, we have the three indexes calculated there, and we can see that more or less in between, at the middle of August, we have a really low or really bad health of a machine, together with a really low or practically none performance, and also regarding the production. This may mean that either the machine has gone completely out of the production time, or maybe that they have gone in holidays. Okay, yes. Of course. I mean, it's in the middle of August, so that may make sense, unless they are on a 24-hour shift. Okay, so all this can be calculated on the fly with the data coming from the sensors from Fint, and then all this data is shared into the different algorithms, so they do their calculations, and obviously the pilot owners can take their appropriate decisions.
And you're calculating those indexes frequently, right?
Yes. If we have historic data, they are calculated based on the historic data. If, for instance, we have an upload every, let's say, 1 week, we calculate them every week because they change that week. But if they are being sent on the fly, they are being online calculated, and they can be calculated every 5 seconds or something like that, if really necessary.
Yeah, depending on the sense.
Exactly.
Right. Okay. Cool.
Thank you so much, Oscar.
Thank you.
So with this, we have actually finished and closed basically 3 out of 4 sections. Are there any questions that have been posted in the chat that might come up now?
Not at the moment, no.
Not as of now.
Okay.
So this would bring us to our final section, which is after we've seen what the technology developers have provided, how this unfolds when it's being implemented on the use cases, and what is the pilot partner's point of view on these technologies from a user perspective. So now we're bringing in our colleagues from our pilot partners, and we will go as usual one by one. Once again, starting with Gorenje. We might have to rearrange a little to see where's the best way to stand in front of the camera.
Yeah.
Michael, you
Yes.
come in between us.
Yep.
All right. So let's see that we're all in the picture.
Yeah.
So
now
we
we're
have
here.
our two colleagues from Gorenje with us. As we've heard, some of the technologies have been implemented on Gorenje site. We've seen the highlights or the targets that were in focus for Gorenje, but maybe Maida, you can introduce a little the specific use case, and then maybe focus on what the project had brought or has brought to Gorenje as an added value from a user perspective.
Yes, Gorenje is one of the very important producer of household appliances in Europe. We produce washing machines, ovens, refrigerators, tumble dryers, and dishwashers. And the dishwasher was also the use case in this Reclaim project, especially the robot cells process, which we want to refurbish within the partners' technologies and with the aim to extend the lifetime of this very old and obsolete equipment.
Okay. How old is it approximately?
It's over 23 years.
Okay.
Yes, 25. Because we have two cases.
Yeah.
One, the second case, our pilot is in Czech Republic in our daughter company Mora, and this was a white enameling line. Which is also very obsolete and old, with high maintenance costs, no more spare parts, and these problems. And it was the same interest to extend the lifetime and to bring the level of the equipment near to the for Industry 4.
Yeah.
Yeah. And I understand you've brought a video, so we
Yes.
can maybe have a little look at what it looks like at Gorenje in the production.
Yes, let's look at the cell A. Probably was told that here was installed the machine vision system. We want to control the small parts which are put it on this plate, and then in the next phase spot welded. And here were already explained probably by Fint and Eliseo Uporto that they made for us predictive maintenance algorithms for this spot welding. And it was installed also the machine vision system.
Sorry that I'm interrupting like that, but that was just the question that was posed or coming up there. So we heard about the predictive maintenance algorithm from the technology developer side, and from a user perspective, what is the use that it has brought to you, and how are you using it at Gorenje now that it's been implemented?
We use this program to have a better maintenance of these welding parts. So we extend the use of the electrodes. This means money, time, and all other benefits. So it's a quite good program to predict the maintenance.
So to me, that sounds like, from your perspective, it has indeed been successful and was of use for Gorenje, probably also to keep further beyond the project. Unless there are any questions from the off.
Yeah, then let's move.
I would say thank you very much to the two of you for introducing what that meant for Gorenje, and we'll move forward to our next pilot.
Yes.
jumping in is
next pilot is coming.
Jose. Jose is actually representing another pilot, Fluchos, so the shoe manufacturing in Spain. And maybe you can give us a little overview of what was being implemented at Fluchos.
Also probably what Advantix contributed to. Yeah.
Exactly, because Jose is actually from the technology provider side, providing sensors and the equipment for the machines to make full use. And how this is being used in the case of Fluchos, we'll hear from him directly.
Yeah.
I'll have to pass on.
Thank you. Yeah, well, in Fluchos pilot, we had a very challenging situation because we had two machines for the shoemaking that were built several decades ago, based on specific requirements for Fluchos. So you cannot find this specific model of machines in the industry. They were just made for them. So as you can imagine, these machines were not capable of extracting relevant data by themselves. So they were manually operated based on the knowledge of the operator. So what we did, and as technology provider, I know better this part. What we did was basically to upgrade both machines by adding, as you can imagine, sensors, electricity meters as well to analyze the work cycles of the machine. We also added, and this is, I have something to show here. We added some piezoelectric sensors in the membrane, which is part of one of the machines, to acquire and to know more about the degradation of the membrane in real time, something that customer was not able to do before. So, considering all this, we also gave communication capabilities to both machines, so that the data scientist guys in the consortium could analyze real-time data from both machines.
And this means actually that in case of Fluchos, or probably for other legacy machines as well, you actually developed individual tailored sensors. Those are not off the shelf, but they're a new development to be able to detect whatever key measures had to be collected, right?
Yeah, exactly. This is, as you said, this is very tailor-made in the sense of we had to analyze the design of the machines. As I said, there were no information about its design, so there was some kind of reverse engineering at some point. So these kind of sensors, for example, these are piezoelectric sensors that will be patented by one of the partners with Tecnalia partners. They will be using these piezoelectrics in similar membranes in the industry. Of course, the membrane will not be exactly the same because this is for a shoemaking industry, but can be replicated. But in any case, this let's say digital upgrade of machines must be some tailor-made service, because it's normally one-of-kind machine that you find at the sites.
As I said before, that we try to implement, let's say, generic algorithm, generic things, because there are a lot of pilots, a lot of technical approaches, but it's useful to have a common approach, but then tailor it to the specific needs. So this is what you did also with hardware, with sensors somehow, because you said, okay, you can also use it, or they can also use it for, say, measuring the, what is it, the membranes, or what is it?
The membranes deformation.
Deformation of the membranes, of course, in other processes as well, but it's in principle, it's a common technology.
In this case, the membrane is the critical component of the machine, because it is the component that breaks down and makes the machine stop. So you can imagine that if we improve the knowledge of the degradation of the membrane, we can replace it before it breaks, so we can avoid some hard maintenance activities in the machine. So it has a lot
keep
of
the
benefits.
effectiveness on a high level.
Exactly.
also avoid the big failures of the machine, I guess.
Exactly.
Okay, cool.
Exactly. Yeah.
Okay. Okay, thanks a lot.
Thank you.
Thank you so much, Jose. Coming onwards to the next pilot, or I'm looking at our director. Let us pose the question.
Yeah, maybe I take the microphone, it's easier to understand. So, are the digital retrofitting solutions used in the different pilots tailored for that specific application is the first question. And the second question is an additional one to the first one, is how easy is it to transfer these solutions to other industrial applicants?
That's a good question.
That is a very good question.
Yeah.
Did you want to pass it?
Pass directly to Jose, yes.
Yeah, well, the quick answer is that it's not easy. It's the digital retrofitting of a legacy equipment is an added value service. It's something that an AI model cannot do that, so it's good to have humans on the loop here. So it's I mean, part of the discussions we had during the project on how to exploit further this service is basically based on that engineering knowledge of different machines in the industry. Of course, this cannot be replicated easily in all the industries, but the knowledge we gain by these actions, by this reverse engineering I was mentioning before, I would say it's a nice tool to address other markets, especially those markets where we can find small or medium companies that have operated the same machines for a long time, so they are looking for some services like this that can prevent them to buy new ones, new equipment, that probably it will be difficult to hire operators for these new machines and so on. So yeah, this is the quick answer, but yeah, of course, this is a challenging point to exploit this service.
Yeah, but it's also an opportunity, as you said, for service providers doing these activities. Right? Okay, cool.
Okay, well, thanks a lot, Jose.
Yeah.
And we come to our, am I counting right? Fourth? Fourth pilot.
Yeah. Podium.
We're going from metal earlier to wood now. Woodworking.
Okay, I go there.
You come over here. Yeah, bear with us. But I think this keeps it fresh. So we have Podium with us, and Asia, you're here on behalf of Podium. What brought Podium to the Reclaim project? What was the motivation for you, the colleagues, the team of Podium to join? And then, of course, very interesting now that we've heard about the technologies and after they've been implemented, what have you been able to achieve with the implemented technology on Podium side?
Okay, so a longer question.
Yes,
exactly.
What brought you to the project?
Yes, okay. Podium is a small, medium company, so as you know, specialized in the furniture wooden of product. So for us, or in general in our sector, the digitalization and the innovation is not a common aspect inside the company. So this type of project allow us to know and to meet new knowledge and new competencies that we have not the possibility to meet our daily work. So this is the main reason to go inside this project. In fact, we have met a lot of people and a lot of new technologies and knowledges that we didn't have. In fact, during this project, we have developed with the whole consortium a lot of solutions and technologies. And for example, we have developed with Links and TTS and FEUP Replica, that is a platform that allows us to manage and to better monitor the production plan and the maintenance time. So maybe now I give the word to Links to explain better.
Yeah, we wanted just to briefly present and showcase a simple demo example of Replica, which is our digital twin enabler.
Okay.
So the role of Replica is to put together all the building blocks of a digital twin, starting from data, of course, and moving from data then to simulations, and in the end to artificial intelligence and data analytics. And all this bring together is useful to get useful insights of what is happening actually on the shop floor. So, yeah.
It's there. It's already there.
So basically, as I said, is a flexible framework. So we tailor-made that for Podium, but is really replicable, as the name said, to all pilots of the project. And the idea is that the user will be helped through simulations to try to understand what's happening on the shop floor. So the idea is to start from basically configure the simulator from basically all the information and selecting specifically which is the week to be simulated, and then the user can see the actual simulation from 3D representations. This part was mainly developed by TTS and was integrated into the system. And through the simulations, the user can see the specific production of a week, and looking at how the machine are actually working and are, occupied with the plan. And then through the user interface, can follow all the simulation process and check when it ends all the results. So basically we can provide all the KPI related to the machine on the shop floor, and specific information related to the performances of the machine, and also the level of the worked parts, and the actual productivity of all the machines, which is really a good insight of from the shop floor. And the added value of the system is the possibility then to compare what is inside the simulation with what is actually on the real data, so coming from the field. So the user can then understand better what is actually the real capabilities of his system. This is basically all the machine have been used at the higher level possible, or there are some gaps that can be filled to optimize the production. I don't know if you want to say.
Okay. Yes, in fact, for us as company, this is a double tool because we could use in two different times. So we could use it before the production. So for example, 2 weeks before the plan of production, in order to understand how to plan the activities that we have to done. The second possibility is to use it after the production, so in order to compare, as Gianluca said, to compare the real production with the simulated one, in order to understand where and in which way we can improve it and optimize it.
Cool.
Thank you so much. I think having all of them here in one line is a testament to the good collaboration within such a EU project between technology providers and the user case or users straight away. So thanks a lot for showcasing this. And this would bring us to our very, well, last but not least, as they say, use case from Harms Wende. Once again, not with the welding machine here, but this time, Felix, you can introduce us to what you can tell about Harms Wende from the user perspective, and what you have brought to us on this table full of different tools and systems. Fill us in.
Yes, okay. So, hello. Yeah, as before mentioned, I think Harms Wende, we are a producer of friction welding machines. So mainly we have so this is a small model. We produce the mechanical part of the friction welding head. So we have a spindle and we have cylinders, and we also build the control, and we are doing the programming. And for all who do not know what is friction welding, so friction welding, as you can see here, different parts. One is rotating, one is fixed on the ground, and then they move together, and due to the rotation and the force, the friction generates heat, and then the process is stopped immediately. Perhaps, I don't know if you can see it here in the video. It's a slow motion video of the process. The machine stops immediately, and both parts are connected. In this video, perhaps see it here. It's a tube, and there it's a metal piece here, which is welded on this tube. And yeah, this one here is an explosive part, and it's used for belt tensioner. So in case of emergency in a car, the belt is tensioned due to this explosive part inside. So it's a safety part. So this is one part we are welding. Okay, and yeah, so before Reclaim, our process or our machines looked like we had an old PLC, which is mainly doing the process controlling. So and we have this friction welding head, but now there are new requirements even from our customers, and so regarding new interfaces, data storage, monitoring, predictive maintenance. And with the old PLC, we were not able to fit this requirements, and that's why we brought this Genius box as a control with new interfaces to our old machine. And together with this Genius box, we have the possibility to have a new HMI, where it's much more user-friendly than before. We have more monitoring possibilities. Now we have an envelope monitoring of our course. And furthermore, all the data that are generated now can be sent via this IoT gateway, which is from the Reclaim partner Find. Data can be sent to dry ice and then can be used for predictive maintenance beams or.
And this all without somehow influencing the process control, which is still on the PLC side, right?
Yes, that's right. So during the friction welding process, only the old PLC has control over it, and after the welding, all the data are sent to the new control. So the process or processes, for example, the one I showed here, this one here is qualified and is not touched. So the process is not touched, but we brought many new functionalities to the old system, and now we're able to bring this new control even to old machines. We can upgrade them. Yes.
Sorry, maybe just one question that came to mind. So with the new information that you are able to gather about the machine and the process, the performance while it's running, does that, I can imagine that affects the relation you were saying, the requirements change from the customers, from the clients. Does that change in somehow how you are approaching the customers now in terms of what you're able to provide, or in terms of the keyword machine as a service that you're thinking of new models of dealing with your customers? Can you say a few words on this, Michael or Felix?
It's your SLA.
Okay. Yeah, of course we are thinking about it, and so our main focus at the moment is still on selling machines. Now we have one customer, as I said, with the belt tensioners, and he wouldn't have bought a new machine if we didn't have this new interfaces, the data storage. So we would have lost the customer, and on the other hand, now we are able to sell this new functionalities to customer, to even then to think about new business models, not to sell a machine, but to
have a leasing model or something like this.
Yes.
but still we're in the traditional market, and so applying different business models is pretty challenging somehow. Yes, yes, right. But we're progressing quite well in this.
It's the first step or first base, probably to start thinking about the kind of circular economy business models. Yeah. But yeah, as we can tell, or as we can see in a lot of cases, I think it's not easy and it comes with its own challenges. But we've seen quite a lot of progress already with equipping the machines, making them digital, and being able to have predictive maintenance prognosis on the performance and such. We have come more or less to an end of our live stream today. Are there any questions, Patrick?
Yes, there's one more question from the audience. So, in general, we see some different visuals about scales and something like how we can read data. So there was a question about how easy it is for you as an engineer or as a user of the system to interpret or to know what kind of data are important and how you can read them and how you can transform them maybe to an action on the machine. So is it quite easy, because we see here these, for example, these scale in your case, so maybe you can say something to this.
So it depends on the data. For example, the curves you can see here that are for the user or the customer, it's relatively easy. There's forces, speeds, so he can interpret them. But then we have new sensors, vibration sensors, and that's not so easy, because and there we need some algorithms in the back that provides the customer more more information. Yeah. So as you can see here on the HMI, this. Yeah, the customer uses, it's relatively easy to understand, but yeah, there are other topics where the customer needs more help from our side.
So there's also the requirement of transforming just data to information, because data is somehow without any context. Yeah. So and information is with the context. So what we are doing there is transforming the pure data coming out of the sensors, coming out of the machines or the controls, into useful information that really is something that the customer or the user can understand. Okay, Patrick, are there no further questions? So we're really at the end.
We're really at the end.
Yeah.
We have seen some of our partners. This is not the whole consortium. In total, it was 22 partners. We have mainly the technology partners and the pilot partners with us today. Tomorrow we're joining for our final partner meeting within the project. But I think this is the time to maybe give a round of applause to all of you for contributing to this project. Making everything that we've seen here today and that stands behind it possible. And me personally, I would also like to thank everyone for the really nice collaboration. I think, having us together here and see how well it works is a testament to that. So thanks from my side, but I would say I'll give the last words to our birthday boy.
Okay, I still have the mic. No, that's fine. No, I do not have much to say, because Melanie perfectly concluded somehow what we did in this project. So there was a really great collaboration. Oh, this is the camera?
Yeah.
Okay. Okay, let's go. Okay. We have some advice from the Regie.
As you can tell, we're not experts at the live streams yet.
Okay. Now, yes, I have nothing more to conclude, to be honest. Melanie summarized everything very well. So it was a really great collaboration within this project, especially when looking at the circumstances with COVID and all those things. Also, we had issues with all major industry had with getting components for putting our technology into reality. So also a big welcome, big thank you to the consortium to make that happen. Also to the non-technical providers, as the guys from Steinbeis and Patrick from ESCI for providing also this live stream. And yes, I think we can conclude. Thanks a lot also for your participation in this live stream, for your questions raised, and thanks a lot. And
we finish on time.
Yes,
Thanks to the captain of the ship, Michael. And well, have a good rest of the day.
Yeah.
And
Bye-bye.
we'll say bye from Brussels.
Yeah. Bye-bye.
Company, so it is also normal in our sector, or at least common for our sector. We did not have the tools to collect what is basically production data, and consequently, we did not carry out any analysis, and as a result, we did not try to improve processes through analysis.
Production manager Maurizio Maschiti and his team decided to digitalize 2 elementary machines of Swiss furniture production in the Reclaim project. Part 1 was the laminating machine, an important production step.
The first thing we did in this machine was to replace the computer, to prepare the computer to receive all the software necessary to be able to expand and improve our workflow. So we replaced the computer to do that. Then we put in a PC system that allows us to interface the computer to the machine. And from there, we are able to collect all the information we need to be able to analyze it in a specific way, then go and act where we need to.
For the Reclaim project, however, not only the computer was renewed, various sensors provide information, for example about the exact edge length and the amount of adhesive used for lamination. With the help of this data, Asia and Maurizio can already draw important conclusions. Besides the technical implementation, there's also the evaluation of the information gained. This is where Podium relies on the support of Lynx. The Italian developers have implemented the replica software solution for Reclaim. This software development is also called a digital twin. Without manually changing anything on the machine, Replica evaluates the data by simulating scenarios and models on the basis of a virtual twin. Decisions are then made later on the basis of these findings. For the young Italian project manager Asia Savino, the development was a real challenge.
Our big